All right, thank you very much. So yeah, my name is Brendan Lundquist. I'm just going to be bringing you through the top 10, or Sarah and I will be bringing you through the top 10 features of IBM Planning Analytics. So let's get started here. Quick introductions to Sarah and myself. We are both business intelligence and or data analytics and BI consultants at Thorogood. Our contact information is available on the screen if you're interested in speaking with us more, perhaps after this webcast. Obviously intentional. Feel free to reach out if you have any questions regarding planning analytics or anything else that you may be interested in learning more about. So quick agenda as well. I'm just going to give a brief introduction to who Thorogood is and what we are, what is exactly planning analytics, the tool itself, and then some of our features or some of the features that we sort of collated that we would like to share with you all today. And finally, how to sort of get started with something like this and how Thorogood can help. Just a quick overview for Thorogood. Who are we? What we do. We are an independent and specialist data and analytics consulting firm with a focus on data engineering, data science, data visualization, and business planning and modeling as well. So our approach is really rooted in understanding business goals and capabilities of different technologies so that we can work with our customers and their business objectives to shape and implement different approaches. We are a global company. We have offices in Asia, Europe, and the Americas. And Sarah and I are actually located both in our Philadelphia office. So we do offer a full range of services when it comes to data and analytics. That includes, different data and technology strategies, roadmaps, implementations, and cloud solutions, user empowerment, and analytics services as well. For our customers, we typically work with large companies, multinational organizations, with a few listed on the screen here. Most of our clients fall into several different verticals: consumer goods, pharma, life sciences, financial services, and insurance. So obviously these industries tend to be very data rich, but obviously we're not limited to these four as well. In terms of the technologies we work with, as I mentioned, we are an independent consulting firm, so that means we really don't work with one specific technology, but we do, however, work and partner with many of the key players within the market to really give our clients the best solution that suits their needs. But thinking about the cloud, nearly all, if not all of these, all of these technologies will have key considerations when it comes to implementation. So Microsoft Azure and AWS probably jump to the front of your mind as entire cloud ecosystems, but we also offer Databricks for data engineering and data science offerings, and Anaplan as software as a service offerings. You obviously see IBM partnering with them as well. So working with these different technologies across industries really allows us to find and select the appropriate tools to work with a customer solution. To give a bit more background to Thorogood and our experience with planning and business modeling, you can see that we have extensive experience of working not only with planning analytics, but also Anaplan. So we have worked to architect and develop many solutions across various use cases in financial and business planning, other operational processes, and also across industries, including consumer goods, financial service, and energy sectors. So that's kind of enough about Thorogood. We'll kind of jump into what planning analytics is before really getting into some of those features for the brunt of this webcast. So for those of you who may be unaware, so IBM Planning Analytics recently added in this Watson functionality, which basically means it's an AI-infused, continuous integrated planning solution that allows you to really transcend the limits of manual planning. And it's really designed to implement collaboration and enable those budgeting and forecasting solutions, some interactive what-if analyses, as well as some analytical and reporting applications. So this solution will really break down business silos so you can quickly create more accurate plans and forecasts for financial planning and accounting, sales, supply chain, marketing, and beyond, really all in one platform. Planning analytics will also allow you to iterate quickly, accelerate decision-making, and drive higher performance by providing an integrated platform, which serves as a single source of truth for your planning and business modeling needs across your organization. So you may have heard of the tool referred to as a number of different names in the past. So I'm just going to give you a brief introduction to the history that allows it to really get to its current state of IBM Planning Analytics with Watson. So it actually started in the early 1980s when an employee of Exxon actually was interested in producing a new planning system to replace their current one. A few years later, that individual ended up creating, or they created the Sniper Corporation, which ultimately released their initial product, TM1. In 1996, Sniper was purchased by Applix, who rebranded the tool to Applix TM1. And in 2007, Applix was acquired by Cognos. which was shortly thereafter acquired by IBM and ultimately rebranded to IBM Cognos TM1. After a lot of iterations and functionality improvements, IBM released an overhauled and rebranded version of TM1 in 2016 called IBM Planning Analytics powered by TM1. Which incorporated more modern functionality like a browser-based interface to compete with some similar planning tools that are available on the market. But between then and now, obviously, there have been a lot more iterations. Most recently, that incorporation of the IBM Watson functionality. The most recent name, obviously, is IBM Planning Analytics with Watson. So the tool is still powered by the TM1 engine, but with a new name. So now Sarah and I are really going to walk through some of the top features of IBM Planning Analytics. And note that this isn't really an exhaustive list, but one that we've really collated to kind of explain what Planning Analytics is today and what you can really do with it. So I'm not going to dig in too deep into each one of these features now, but I'll flash up on screen briefly to give you a sense of kind of what we're going to be chatting about today. And to kind of start off, I'll bring it with multidimensionality. So Planning Analytics is built using multidimensional cubes and modeling principles, which provide a different set of offerings than, say, a tabular model does. So a multidimensional model will be much more conducive to large data volumes for ease of access during any given query. What's also powerful about the multidimensionality, and in turn Planning Analytics, is the flexibility that one may have when wanting to actually access data within a certain view. So take, for example, this cube that I'm looking at that is looking at sales metrics across time for my company. I have my months functioning as my columns and my metrics on my rows there, as you can sort of see. But with Planning Analytics, I can seamlessly pivot these two columns such that I'm now looking at metrics on columns and dates on rows. Although it's a relatively small point, it does illustrate the flexibility that's inherent from a multi-dimensional cube perspective that's available within Planning Analytics. But with Planning Analytics as well, we would most likely want to be able to flick between more than just the two dimensions that are being populated on screen. And because of this multidimensionality, when we're defining our cubes, we can easily flip between different slices and cuts of our data for facilitated analysis. And as you can sort of see here, flipping easily from budget version 1 to budget version 2 across those three screenshots. And while the multidimensionality of individual cubes is useful, we can also leverage the relationships that we can make within Planning Analytics across cubes to support business users so that they can evaluate the impact of their inputs when evaluating their budgets in real time. Within Planning Analytics, let's say that we are forecasting different models of cars, or car sales across time. However, we don't want to do this for one dealership, but instead for a nationwide chain that we're responsible for forecasting for. This is our forecasting cube. But as time goes on, we're going to receive our actuals for each month as we sell more and more cars. Our actuals cube may be populated automatically from either a single data source or multiple data sources across the nation, that obviously are flowing in from all of our dealerships across the country. Despite our forecast and our actuals living in two distinct cubes, we can create process flows to evaluate our performance of our forecasting relative to our actuals in a new consolidated performance measuring cube. However, we also may be alerted to certain issues within our consolidated cube, as you can sort of see on the screen there, like a forecast for a certain model car not living up with its actual sales. Obviously, that's going to be worth further investigation within our Planning Analytics cubes through different views and analyses there. We can take this information from our consolidated cube and make the necessary adjustments to our forecast and ultimately feed back into our plans for the rest of the year. This obviously helps us better and more accurately plan our business going forward. And this kind of adjustment and synergy between multiple cubes is something that's readily apparent within Planning Analytics. So the multidimensionality and the function that sort of comes with it, however, is really ultimately fueled by the calculation engine. So a few years back, IBM took that powerful multidimensional calculation engine in TM1 and added in the Workspace feature, which is just run on containers, to really incorporate the modern reporting capabilities to make activities like planning, forecasting, budgeting more performance than before. So what was historically IBM TM1 eventually became IBM Planning Analytics powered by TM1. So the TM1 calculation engine is, obviously, the one of the most important features to understand about Planning Analytics. Since Planning Analytics is actually powered by TM1, it has all the features that are native to it without really compromising on that capability. The engine is highly performant and can run seamlessly on large data sets which are stored in memory OLAP cubes. And those cubes contain rules for defining any commands and computations are performed in near real time without pre-calculating or can be calculated on demand as needed. TM1 also includes a feature called feeders, which can speed up processing time because not all cells are being loaded at once. and also mitigates some of the performance issues that come with sparsity in a multidimensional cube. Feeders tell the TM1 engine what calculations to perform based on the data in the model and performs only the calculations that are relevant, obviously increasing performance. And finally, parallel processing will enable the tool to function seamlessly, even with multiple users inputting information at the same time, really enabling that collaboration that Planning Analytics will sort of thrive for you. So now that we really have an introduction to multidimensionality and the calculation engine that set the foundation for planning analytics, let's drill down to some of the more granular features and capabilities that are inherent to these core components. Start with MDX. And MDX is a programming language that drives the analysis and the querying ability that powers planning analytics. MDX is specifically used to query multidimensional data within OLAP cubes and is really what's driving planning analytics processes and functions from a programming perspective. To the right there, you'll see an example of scripted MDX. And for those familiar with SQL, you'll see that in this particular instance, it looks quite similar with like components with a select, a from, a where, and really those are the statements that are driving what is available in a given view or cube. With MDX as well, you also have the ability to create subsets and views. And I suppose to start, subsets are used to really select, group, order, and save lists of elements of data that an individual would be interested in analyzing. And there are two kinds, static and dynamic, the latter of which is powered by MDX. But what exactly does static and dynamic really mean? A static subset, as the name suggests, is something that you know is not going to change when developing your application. So a clear example of this obviously would be something like months. There's always going to be 12, so it's easy to define your static subsets based off of this. Whether it be by quarter, by season, or what have you, whatever you deem appropriate for your planning application. Dynamic subsets, however, are much more powerful due to the automatic updating that is inherently available within them. As an example, let's just say I'm a company that sells fruit. Currently, we only sell 3 fruits, apples, pears, and oranges. But our store will now be selling, say, another fruit like bananas in the future, and our sales actuals will start flowing into our planning cubes starting next month. Instead of having to completely redesign our cubes to accommodate these changes in our future sales accordingly, the dynamic subset is going to pick up the fact that I'm now selling bananas and can flow into our cubes throughout our entire system. Obviously, this is quite a silly example, but if I were an organization that had thousands upon thousands of UPCs that were selling on any given month and sort of being swapped out every month as well, that would mean I wouldn't have to worry about my cubes not accurately reflecting what I'm actually selling to my customers, which I believe is quite key and quite powerful. And lastly here, to see your subsets really come to life and actually report them, you have different views. And views are simply slices and cuts of a defined cube to facilitate that data analysis for your end users. So it's the flexibility of the views within planning analytics where the dynamicism and the multi-dimensional capabilities and ultimately the power of the tool really begin to make themselves visible and the value of planning analytics to truly be realized. So with that being said, I'm going to hand it over to Sarah now, who's going to bring you through the rest of the features for the duration of this podcast.
So now I will talk through the remaining features we like about planning analytics, starting with drill down paths. Planning analytics, like other similar tools, also offers the functionality to drill down into your TM1 cube, view, or relational tables you're working with to allow users to view more detailed data on a specific cell and also get a view of more information from the data source. This feature allows you to quickly and easily understand the origination of data in your model and any calculations that may be impacting a cell, all with a couple clicks. You can drill down into multiple levels of your report as well. And once you view the drilled down data, you can also save that view and export it as a CSV for further analysis if needed. Drill down paths are also possible for cubes and relational databases as well. The cube drill through is a drill through process on a TM1 cube or TM1 view data source. Drilling down onto a cell connected to a cube data source will open up the drill through viewer pane, which is interactive to the viewer. On the other hand, the drill through is also possible with relational database connections, such as an ODBC or flat file data source. Drilling through into a cell here will open up the table viewer, which is non-interactive to the viewer. Drill through is available within Planning Analytics Workspace and Planning Analytics for Excel, both of which we will learn more about shortly. Next, as part of a rebranding a few years ago, IBM Planning Analytics introduced the sandboxing feature, available in both Workspace and Planning Analytics for Excel. This feature is super helpful in that it allows the modeler to create your own personal and different versions of reports where you can test out planning different scenarios and change base data without impacting the end users. Some aspects to business planning take a few different iterations before being ready to release to users. With sandboxes, your production reports and data remain unchanged while you test out the impacts of multiple scenarios. These sandboxes are private, meaning that they're only able to be viewed and accessed by you. Other users cannot access your personal sandbox, so there will never be any confusion over what plans are the most accurate and up-to-date. Once you're happy with a particular scenario, you can commit it, which will update the base data with the committed data, and submitted sandbox will then become available to other users. In this example on the screen here, we decided that scenario 3 was the best and committed that scenario, which updated the base data and feeds back to the reports. Next, we have the ability for cloud or on-premise hosting. In a major overhaul that was released about 2 years ago, IBM introduced the functionality to allow customers to choose Planning Analytics as a local software or software as a service deployed on IBM's software cloud. The great thing about this is that you can get the same tool with the same functionalities, but your organization can choose which is best for them. For Planning Analytics on the cloud, the system operates in an environment hosted by IBM as a traditional software as a service. This means that no physical hardware to install, store, and maintain. You can get started quickly without the overhead of getting the hardware set up. The local on-premise version allows customers enhanced control over their environments and that you're able to get the software installed on your own servers and maintain them yourself. This is more of a traditional way of working with softwares, as we've seen companies using this option if they require enhanced security or do not want their data hosted by a third party. IBM providing the flexibility to choose between 2 hosting options for Planning Analytics is a great feature in that it allows customers to choose the best option for them. If you don't want the hassle of maintaining the software on your own servers, then the cloud option is best for you. If your organization requires enhanced security, then the on-prem version is best for you. Next, Planning Analytics Workspace is the next feature that we consider one of the top features. Workspace is a web-based interface that allows users to plan, create, and analyze your content right in the web browser, so no applications need to be installed on your machine to use it. You can access Workspace through IBM Planning Analytics in the cloud or as the local on-premise software. Workspace is relatively new and rapidly evolving with frequent updates and enhancements. A key draw to Workspace is the user-friendly nature to it. Along with the capability to perform your modeling in Workspace, there's also the functionality to create user-friendly reports and visuals that can be accessed right in the browser as well. So here's an example on the screen of what that kind of looks like. You can see that it's highly customizable, so you can input your organization's logo and custom colors. You can also link to other reports on the screen on a page, as well as include custom filtering options. There's also the option to create many different visual types, such as maps, pies, and regular tables for in-depth analysis. Another great feature that is available for IBM Planning Analytics is Planning Analytics for Microsoft Excel, also called PAX, which provides the functionality to connect to your Planning Analytics models directly from Excel. To enable this functionality requires installing an add-in to Excel, and there are licensing considerations that come along with this as well. This allows report authors to build reports and analyze data using data sourced directly from Planning Analytics. This is a great option to use for those who may be more comfortable with Excel versus a new tool like Planning Analytics, or maybe if your reporting strategy revolves around Excel spreadsheets rather than a centralized Planning Analytics worksheet. You can provide full access to cubes, views, dimensions, hierarchies, and elements, all to be utilized within Excel. Once you install the add-in, you will see a similar view here on the screen. With IBM Planning Analytics tab on the top, you can see the top ribbon there are various options to choose from. Like in the Getting Started pane, you can go here to start connecting to your Planning Analytics models and show the task pane, which houses your cubes and dimensions. You can also open existing projects or versions. In the Add Data pane, you can change the format of tables and view lists. And then in the Data pane, you can refresh your data, drill through to a lower level, or clear the pane entirely. From the Dynamic pane, you can also rebuild sheets, books, and show format areas as well. Here is a view of the interface connected to a data source. You can see on the left-hand side that there's the option to view the different cubes and dimensions that you can connect to. And then looking at the main pane, you can see the view looks similar to an Excel file typically, showing your rows and columns populated based on the connections to your Planning Analytics model. Planning Analytics for Excel also offers more formatting functionality and familiarity that can be performed within Excel and does not exist within Planning Analytics. It can also provide higher quality, more pixel-perfect reporting, which can function as a way to prepare your reports for downstream presentations and distribution. Next, we have the Turbointegrator. The Turbointegrator, or TI for short, is the powerful ETL tool that exists within Planning Analytics. Being that we're working with a multidimensional model within Planning Analytics, the Turbointegrator is unique in that it revolves around cubes. But that does not mean that the TI can pull from data that exists only in multidimensional manner. While it can bring in data from other cubes that you have defined within Planning Analytics, you can also bring in the data from delimited text files and ODBC-compatible database tables. Being able to combine data from other sources and bring them into Planning Analytics will enable users to interact and plan from an interactive interface with consolidated assumptions and numbers. When bringing in your data to Planning Analytics, you obviously want to be bringing it into the cubes, but that's not to say that you need to be creating new cubes every time your TI process runs. You can also update your cubes with the latest data to ensure that users can work with it as they see fit. The Turbointegrator is merely just the tool. The Turbointegrator process is what is actually running to populate your application. There are certain characteristics within a process that are part of its definition. First, we have variables. Variables are defined to identify columns within the data source that are being brought in. Then there are maps. Maps determine relationships between variables and data structures in the TM1 database. Next, procedures define the actions to be executed before data source processing, metadata structure setup, actual data transformations and updates, and a closing procedure as well. You are also able to define parameters to generalize the process such that it can be run irrespective of any manual effort. If you wanted to string together multiple processes to execute, you can create a chore. With chores, you can also set the times and dates for processes to be run in whichever order you determine. Within each process, the brunt of what is actually being executed is driven by the content of functions within your prologue, metadata, data, and epilogue procedures in your TI process. As well as with most programming languages, the manner in which your activities can actually be defined is very flexible, and there's a lot in which you can do within the processes to transform and prepare your data and data structures as you wish, including cube, hierarchy, subset, dimension manipulations, process control, and also ODBC-related functions. What's most powerful about TI is not only that you can leverage these ODBC connections for reading purposes, but you can actually also leverage TI processes for writing back out as well. By combining the abilities of reading from standard data sources, allowing your users to take that data and add in their own manual assumptions and write that out to another standard database to be leveraged by further downstream applications is extremely valuable from a data ecosystem perspective. To further speak about system connectivity that can be enabled within Planning Analytics synergy with other data ecosystem components, let's speak a bit about what something like that could actually look like. First, we start with Azure Synapse, which is a new analytics service from Microsoft Azure that brings together enterprise data warehousing and data analytics. Synapse was formerly known as Azure SQL DW, but has now evolved to be much more conducive to machine learning at scale. For our purposes, however, we can note that Synapse is an ODBC-compatible database, which lends itself to being able to communicate with Planning Analytics. It is important to note that this is just an example, and as mentioned earlier, Planning Analytics will be able to read and write to any ODBC-compatible database. We have a TI process in place to generate our required cubes for multidimensional modeling. With our cubes generated directly from the Synapse database, our users can go into their workspace and model how they would for their typical business processes. Once we're happy with their outputs, we can write the outputs of those cubes back into Synapse using another TI process where it can be stored within our wider data ecosystem. Our outputs are now accessible by other applications, including something like Azure ML, which is a cloud-native analytics solution to manage and deploy machine learning experiments. We can take our modeled outputs and now apply these new inputs to various ML models. Depending on our business, we could look to generate more accurate forecasting models based on our assumptions and inputs, potential improvements to our modeled inputs for our users from a budgeting spend perspective, and much more. And lastly, although there are some visual components within Planning Analytics Excel, we might want to visualize our business user inputs in conjunction with some of our ML model outputs, or perhaps some other data sources with a tool like Power BI. We can see all three to provide a unique view into our planning and our modeling outputs and pertinent information that may live outside of Planning Analytics. So now you know a bit more about the cool features that are in IBM Planning Analytics, and you may be wondering how to get started using the tool. As Brendan mentioned previously, we have a host of experience in planning and business modeling in general, and we've worked with customers across a wide range of areas in this space, from developing POCs to enterprise-ready solutions as well. If you aren't ready for that yet, we have a ton of content related to planning and business modeling on our website you can find on the link here on the screen. This consists of webcasts similar to this one, multiple case studies detailing how we implemented solutions for our customers. Thanks again for joining today's webcast. We hope you enjoyed the content.